So here in this video, we're going to have a look at the cumulative distribution function. The cumulative function itself, you would recognize from our work in the binomial and with the Poisson distribution. The definition of capital F of x is going to be the probability that x is less than or equal to the value small x. So capital F of 5 is the probability x is less than or equal to 5. We're going to find that by integrating in between the smallest value in this interval and the actual value x. So we're going to do an integration with x as the upper limit and the smallest valid value as the lower limit. If we do that, we will generate a function where we can substitute any x value in. Just like in the diagram below, we can substitute any x value in, and we're calculating this blue area. We're calculating the area right from the bottom of the function up to and including the x value we've substituted in. We could do a separate calculation every single time, but we want to generate a function that will be useful for us in many ways, including helping us to find the median, the quartiles, percentiles, rather than having to do the integration for every value we're tasked with finding. We'll look into that more later on in the course. So as we discussed, we're going to integrate in between x and the lowest valid numerical value in the interval. So in this case, we're going to integrate in between x and 1, 1 being the lower limit of the interval. Okay, so just substituting into this general expression, integrate in between x and 1 for the function 1/4 x dx. Okay, like I said before, I would always factorize out any constant, so I'm going to factorize out the 1/4, and that leaves me with just integrating x. This just makes, especially in an exam situation, it just makes the integration a lot easier to see and to verify. So when I integrate, I get half x squared, and actually at this point I'm also going to factorize out the half. So that'll give me 1/8 on the outside, and then I'm just substituting into x squared, all of which I should be able to just do in my head. Okay, so x into x squared is obviously going to be x squared, and 1 into x squared is going to be 1. So my function is 1/8 of x squared minus 1. I could expand at this point, but there's not much benefit to expanding. I'm happy to use this in the cumulative distribution function. Okay, so I'll just set out my brackets, capital F of x equals, and then this symbol is the piecewise symbol. This means that there's going to be multiple lines or multiple functions to follow from here for different intervals. Okay, so let's just start with the function we're working on. So 1/8 x squared minus 1. This is the function for x being in between 1 and 3, including the 1 and the 3. Any x value below 1 is going to have a probability of 0. That must be included. And any x value above 3 is going to have a cumulative probability of 1. So this piecewise function says that there's 3 different outputs that we can follow. 0 is what we follow for the case where x is smaller than 1. The function we found if x is in between 1 and 3, and the value 1 if x is greater than 3. Okay, once again, let's have a look at what happens if we have multiple functions. So here's a PDF, and you might recognize this one from the last lesson, where we have 2 different functions over 2 different intervals, and we need to find the cumulative distribution function. Okay, so let's do what we would usually do. I'll start off by wanting to integrate for the first function in between x and the lower limit of the interval. So that means I'm integrating between x and 1. I'm integrating the function which is 1/5. And like I said before, I always want to factorize out any constants. So I'll take out 1/5, which just leaves us with 1. 1 is so easy to integrate. So I'm going to have 1/5. My square brackets are going to just have x, and the limits are going to be x and 1. So I have 1/5 x minus 1 in brackets. Okay, so that's my function for the first interval. The second interval. So this time I'm going to be integrating in between x and the lower limit of the interval. So I'm integrating in between x and 2, and the function is 1/5 x minus 1. You know what I'm going to do already. Let's factorize out the 1/5, and I'm going to be integrating x minus 1. And that gives me 1/5, and in the square brackets, a half x squared minus x. Limits being x and 2. Okay, as we substitute into that, I've got the 1/5. X substitutes and basically duplicates what we had in the square bracket, and we're subtracting 2 substituted in, which will give us 2 squared over 2 minus 2, which ends up being 0. So the second function that I've calculated is 1/5, a half x squared minus x. And this time I am going to expand, and there is some value to expanding, and you'll see why in a second. That gets us 1/10 x squared minus 1/5 of x. Okay, this is not ready to go into the cumulative distribution function just yet. Well, when we have multiple intervals and multiple functions over those intervals, we initially are going to calculate the cumulative function that's only going to be valid for the first function. So here it's valid for the orange function all the way up to 2. We're going to need a different cumulative function for the second interval. We can calculate that cumulative function. This function, 1/10 x squared minus 1/5 of x, is only going to find the blue area. This is going to be the blue area only. The definition of the cumulative function in this case is the probability of it being in between 1 and the x value we've substituted. This function calculates the probability between 2 and the x value we've substituted. We need to add on the orange area to fulfill the definition. How do we know what this orange area is? We're going to go back to the original function, and we're going to evaluate that for 2, as in, what's the maximum probability we would get from this original function? What's the maximum probability we would get in this initial interval? So we're going to calculate capital F of 2, which is 1/5, 2 minus 1. It's 1/5. This orange area is going to have a probability of 1/5. I need to add this on to the function we've just calculated, and that will give me the true cumulative from x all the way down to 1. Okay, so let's just write this up in the correct form. So we've got the 0 and 1, that's always going to be there. Don't lose marks by missing that out. The first function is 1/5 x minus 1. The second function is the 1/10 x squared minus 1/5 of x, and then we've added on that 1/5 for the initial interval. Let's assign the correct intervals to each of these. These should really just match what we have in the PDF. And then for the 0, we'll make sure it's less than 1, and for 1, we'll make sure that it's greater than 4. Being careful to make sure the signs here don't overlap. Since 1 was included in the 1 to 2, it's not included in the less than 1. Since 4 was included in the 2 to 4, it's not included in the greater than 4. And this is the cumulative distribution function, and this is the technique you need to use when you have multiple intervals or multiple functions. Okay, so now that we know how to calculate the CDF, the cumulative distribution function, we want to make sure we can make good use of it. Here, we're given the CDF, so that's actually our starting point. We haven't been asked to find it, we've been given it, and we've been asked to do a few things with it. Firstly, find the probability that x is less than or equal to 1.5. So, this is the purpose of the cumulative distribution function. We want to be able to substitute in a value and find the probability that it's less than this particular value. So we're just going to substitute 1.5 into this function. If there were multiple intervals, we'll just choose the valid function for the value we're working with. Okay, so this is 1/5 of 1.5 plus 3/20 times 1.5 squared, and that gets us 0.975. Part B wants us to find the probability that it's in between 0.5 and 1.5. Part B wants us to find the probability it's in between 0.5 and 1.5. If we were starting from the PDF, we could integrate in between these two values and get our answer. But we're starting with the cumulative distribution function. So to find this, we're going to need to do the f of 1.5 minus the f of 0.5. So in part A, I found capital F of 1.5. Let's find capital F of 0.5. So a similar calculation, 1/5 times 0.5 plus 3/20 times 0.5 squared. Okay, and that gets us 0.175. And as I said, we're looking for the difference between these two. 0.975 subtract 0.175, and that leaves us with 0.8. Part C of the question. This would be a 1 marker. It really wants to test your understanding of the cumulative distribution function. As I said when I very first introduced this, we cannot find the probability of one exact value because we're working on a continuous distribution. There's an infinite number of values, so the probability of any one value is infinitesimally small. So small that we just refer to it as 0. The probability that x equals 1 is going to be referred to as 0. Part D, however, we're asked to find the probability density function. We're asked to find small f of x. If we had to integrate to find the capital F of x, to go back to the small f of x, we should be differentiating. So let's go ahead and process that differentiation. Gets us 1/5 plus 3/10x. Okay, and we just need to write that into the PDF. So the probability, so f of x equals 1/5 plus 3/10x, and that's valid for the interval 0 to 2, and it's going to be 0 otherwise. It's going to be 0 for all other outcomes.